Okay, so what's today? Today's Monday the 5th. Okay, so I got to work with the testing center schedule. So these, am I recording? Oh, I am recording. Okay, so the test is going to be, the computer test is going to be Wednesday or Thursday. Apparently they don't like me to end it on Fridays anymore. So whatever, okay? Wednesday, Thursday. So we will have a review on Wednesday. We'll have the written test on Thursday in class. Computer test will be Wednesday or Thursday at the testing center. This Wednesday, yeah. So we'll go over today and tomorrow, and then review on Wednesday. Okay. All right. Any? Yes.
What sections are going to be on there?
What sections are going to be on there? Everything from the last test up through probably 9.3. I think that's what we'll cover tomorrow. So, all right. So we're going to start on 9.2, which is confidence intervals for a mean. Okay. Now, I'm going to turn on the light. The first thing that you should ask yourself when you're doing a mean, right? We're doing a mean, M-E-A-N, okay? Is, do I know population standard deviation? Okay? There's only two answers to that question. Those two answers are?
Yes or no.
Yes or no. Okay, if the answer is yes, then you're going to use a Z distribution. Okay, the one that we've been using all along. If the answer is no, we're going to use a T distribution. So we got a new distribution today. Okay, they're very similar. The charts are really different though. Okay, I'm going to concentrate mainly on the T distribution because it's new. I want to give you both formulas really quickly. They're very, very, very similar. Okay. If the answer is yes, okay, your formula is going to be x bar plus or minus z sub alpha over 2 times the square sigma over the square root of n. Okay, that's if it's a z. If it's a t, once again, very similar, x bar plus or minus t sub alpha over 2 times s over the square root of n. Okay? So the t versus the z, the s versus the sigma. Okay, those are the main differences. Everything else is the same. Does that make sense? All right, so let's talk about the student t distribution. I'm going to focus on t, but I don't want you to forget z. Okay? All right, so it was discovered by a guy by the name of William Gossett, using the T, I guess, and he wrote it under a student name, a pseudonym called the student T distribution. To be honest, he actually used to work for a beer company, so we got this from beer, I guess. So the T formula, T equals x bar minus mu over s over the square root of n. Okay, so you're going to notice a tremendous number of similarities with the Z distribution. Okay, the formulas are very similar. We're just substituting our sample standard deviation rather than our population standard deviation, and it's used when population standard deviation is unknown. Okay. All right. So some properties. Number one, the shape is different for different degrees of freedom. Number two, it's symmetric and centered at 0. Number 3, the area under the curve is, I'll bet you guys know. What do you guys think? 1, very good. Number 4, as t approaches each end, the graph approaches 0. Number 5, the tails are larger than the normal distribution. And number 6, as n increases, becomes like the normal distribution. Okay, so the nice thing is, if this is the normal distribution, then this will be the t distribution. Okay, so it looks very much like a bell curve, only you've got larger tails. Okay. Now we also have a thing called degrees of freedom. Degrees of freedom generally equals your sample size minus 1. Okay. So a couple things I'd like to do. Let's just look at the chart for a minute here. Where's my chart? There it is. Share. Okay, so I think I mentioned this before. Okay, so important thing to look at when you're looking at your chart. This is the z distribution. Notice it tells you the area to the left. Okay, so always look at that to make sure you know what you're looking at. With the, why isn't that working? With the t distribution, it gives you the area to the right. Okay, so let me ask you a question. I want you to find the critical value for 95% confidence interval with 6 degrees of freedom. Okay, so here's how you're going to do that. Okay, now, in fact, pictures are still helpful. I'll use the purple. I think it'll be easier to see, especially on the video. So if I've got a 95% confidence interval, how much do I have in my tails? Got 95% here. Say it again. 2.5% in each tail. Okay, so if I'm doing a 95% confidence interval, my alpha over 2 is 0.025. Does that make sense? Okay, so if I'm looking here, I want to look at the 0.025 column. I really wish that my touch screen worked. Try to make that a little bit bigger. Okay, so I'm looking at my 0.025 column. Turn this off. Turn back on. Might take a long time. Maybe that was a bad idea. Oh, that was a bad idea. Okay, so we're looking at the 0.025 column. We're looking at 6 degrees of freedom. If you guys have a chart in front of you, hopefully you see the chart is 4.317. That's a bad idea. Does that make sense? Do you guys have your charts in front of you? Sorry, I shouldn't have turned off the screen. I thought I would fix it, but all I did was mess myself up. Okay, does that make sense?
What number are you supposed to do?
4.317. Oh, actually, I'm in the wrong column. 2.447. Yeah, I was looking at the 0.025 column. 2.447. Does that make sense? See if that fixes the board. Okay. All right. So while the computer boots back up, let's do an example. Go ahead and open up your Excel. Let's say that I'll read this aloud. An arborist, oh my goodness, an arborist there we go, we're back. An arborist wants to determine the mean diameter of mature white oak trees. The data represent 7 mature trees 1 meter above the base. Treat as a simple random sample and construct a 95% confidence interval. Okay, so you're collecting real data this time. 64, 33.4, 5.8, 56, 51.5, 9.2, 63.7. Okay. All right. So you've got real data here. You collected this. You want to create a 95% confidence interval. How would you do such a thing? What question should you be asking yourself? What did you say? Is this enough data? That's a good question. Do we know the population standard deviation? Even better question. Okay. Do we know the population standard deviation? No. So is this going to be a Z or a T? T. Now, ideally, we would do a QQ plot and make sure it looked okay. I don't want to run out of time today, so we'll pretend that it's normally distributed. Okay. So yeah, do I have enough data is a good question. But we're going to assume that we do. We're going to assume it, actually, we're going to assume it's normally distributed. It's a small sample. For some reason, we can't find these, rare white oak trees or something. I don't know. Okay. So we're going to use the T distribution. Okay. Now my formula is going to be X bar plus or minus T sub alpha over 2 times S divided by the square root of N. Okay. So the first thing I need is X bar, right? How do I find X bar? What did you say? Find the mean, average, curse go gates when you do that. Okay. We love a soft rule. We just hate that it doesn't know the stat terms. Okay. We also need the T sub alpha over 2. Now I got a computer. So you saw how to look it up on the chart, right? How do you think you would figure out the critical value for a T distribution? T dist or T inverse, one of those. It's actually going to be T inverse, okay? Now, by the way, there's a couple of different ones, okay? There's there's one with periods, the one without. So actually, this is a case where the one with the periods works. Now look at this. I got T dist two-tailed, T dist right-tailed. I got T inverse and T inverse two-tailed. Okay? Is my confidence interval two-tailed? Yes. I can use that one. Now here's where I can't remember if I'm supposed to put 0.05 or 0.95 here. We're going to find out. 0.05, we're going to see if that's correct. And your degrees of freedom are 6, because we got 7 trees, right? And hopefully we get an answer close to 2.447. It's a good thing I looked that up already, so I know what the answer is supposed to be. Oh, look at that. Okay. Now, by the way, what happens if I put 0.95 here? I get the wrong answer. Okay, so it's asking you for the area in the tails. The area in the tails is 0.05. Okay, so that gives you the T sub alpha over 2. I also need the S. What's my S?
Which formula did you use? T dot.
T dot inverse.
I mean on Excel to get that.
Two-tailed. T dot inverse two-tailed, and you put in 0.05. Because you're putting in the area of the tails. Okay? What's S? Which standard deviation? Which one? Sample standard deviation. So I'm going to use equals. What is it? S tail. Standard deviation. Highlight my data. And my N, I might as well get my N. My N is 7, right? My degrees of freedom is 6. Okay? All right, so I'm going to do my lower. I'm going to do my upper. And then I'm going to have you guys interpret this for me for a minute. Okay, so my lower is going to be my X bar minus my T sub alpha over 2 times my S divided by my square root of N. Okay. Now, can I copy it and paste it? Can if I do it right. I don't want to copy it there. I want to copy it up here. If I press Control C and then Control V, it should get the same answer. What's the only change I make? Change that minus to a plus. Okay. And then I would like Tanner to interpret this confidence interval for me. I gave you a nice pattern last class. That was over the weekend, so. You look at your notes from Thursday. You didn't write it down? Who wrote it down? Who wants to give me a good confidence statement? Ashley did. You write everything down. We are 95% confident that the mean of mature white oak trees diameter is between 6.33 0.84 centimeters. Okay. Study with Ashley. She knows what she's doing. Okay. Does this mean that 95% of oak trees are between 36 and 61? No. Just the mean is between there. Okay. All right. Now, let me ask you a question. What if I said find a 90% confidence interval? Let's we'll do it with the chart. Now, my first question, before we do that, is my interval going to be bigger or smaller than the one I just found? Smaller, right? Because I'm becoming less confident. So that's going to make the margin of error bigger. Does that make sense? All right, this time we're going to use the chart. Do you have a question?
Yeah. So in Excel, you did the mean minus the t-score divided by those things. Why is it the t-score when the equation on the board is the x bar minus b?
I didn't understand your question.
Never mind. I was looking at the one underneath the standard deviation.
No, this is the one you're supposed to look at.
Okay. That makes sense.
Okay.
Sorry, I was looking at the equation down to the left.
Oh, this one? Oh, no. Honestly, we'll use that equation. We don't really need that till chapter 10, but they introduced it to you now. So just kind of to show you that it's really similar. Everything's really super similar to the Z distribution. All the equations are the same. The only thing that we add is your degrees of freedom. Okay. So 90% confidence interval. This time we'll use the chart. Okay, so I'm going to do my T sub alpha over 2 from the chart for 90%. Let's just refresh this. How do we do that? So we're doing a 90% confidence interval. Okay. What am I looking at? Chris, it must be your turn. We're looking at the 10%.
No, the 0.5.
We're looking at the 5%, right? Because we drew our picture, we know that it's going to be half of that. It's half of 10, which is 5. Okay? And we're going down to what degrees of freedom? 6 degrees of freedom, and so we get the answer. It's not working today. It's really annoying. I like a smart board, not a dumb board. What is that number?
1.943.
1.943. Okay, so we're going to use that in this case. Okay. All right, so let's do our lower. We'll do our upper. It's too low. Is that better? Okay. All right, so whose turn is it? Sean, it must be your turn. Can you help me do this interval?
Yes, we do. Equals the x bar.
Okay, x bar minus.
E.
And what value is that?
2.44.
No, we're doing a 1.943 this time. Okay.
Times that by
S
s. And divided by the square root.
divided by the square root of n. Okay. Now I copy that, paste it, change that minus to a plus. Okay, so as you see this, we went from 36 to 61 to 38 to 59. So definitely, the less confident you are, the smaller your margin of error. Does that make sense? So another way to think about this, okay? I'm 100% confident that it's between 0 and 1,000. All I got to do is make my margin of error huge, and I can be super confident. Okay? Does that make sense? I'm 50% confident that it's between 40 and 50. I could be wrong. Okay, but I got a nice small interval though. Okay, so that's kind of the trade-off. Do you want a big margin of error or a small one? That's how you mess with that. All right, so the last thing I have here, most of your homework is going to be on the T distribution, because that's the new distribution, but don't forget the Z, okay? Formula is almost identical, since we're so suited the Z for the T and the standard population standard deviation for the sample. Those are the only differences, okay? All right, so now, right here, sample size. Here's your sample size calculation, okay? So your N is going to be Z, we are going to use Z this time, not T. Z sub alpha over 2 times sigma divided by E, where E represents your margin of error. We're going to square that. Okay? So let's say, for example, let's just do a quick example here.
That's Z sub what?
Z sub alpha over 2. Okay, so let's say you want to estimate the mean speed on a road with a 2 mile per hour margin of error. With, how confident do you want to be? Let's be 99% confident. 99% confidence. How large of a sample do you need? Okay. So I'm going to have to figure out, according to my formula, I've got to figure out my Z sub alpha over 2. I'm going to need my sigma. Oh, I guess I forgot something there. And I'm going to need my E. So what am I missing there? I need some more information in order to do this, don't I?
Yeah.
Assume the highway patrol tells you the standard deviation is 8 miles per hour. Okay? So how do I figure out my Z sub alpha over 2?
Just 90%.
So if I'm using my computer, I could look at the chart, right? What's the command for the computer?
T dot inverse.
Norm S inverse, because we're using the Z this time. Probability. If I'm using 99%, what's my probability? I can't remember. Hopefully it's 0.99. We're going to find out here. It's going to be, if we're using the 68, 95, 99 rule, it should be about 2.575, I think. Oh, 2.32. Yeah, that's right.
On the chart it says 2.575.
Oh, it does say that on the chart? That's the easier way to do it. Yeah, that's what I thought. Oh, what did I do wrong? I got 2.33. Why did I get that wrong? The chart should be able to tell you why. If I'm doing a 99% confidence interval, how much do I want in the tails? 0.05, right? 1% in both tails, so half of that. So I forgot to divide it in half. That's why I got my number wrong. Okay? So 0.995. Now I got the right number. Okay? Or you can look at the chart. The computer's obviously going to give you more decimals. Your sigma is what? 8. Your margin of error is what?
2.
2. So n equals Z sub alpha over 2 times sigma divided by margin of error. I got to raise the whole thing to the second power. Put the parenthesis in the front. Okay, it says 106.15. What is my sample size? 107, right? Okay, that's the biggest mistake people make is they don't round or they round improperly. It's not 106 because 106 would be too small. I need 107 to get 99% confidence. Okay? All right. So like I said, the homework is going to focus mainly on the T, but if I throw a Z at you, don't be surprised. Okay? All right. See you tomorrow on the quiz on 9.2.